Hi, this is Christopher Boucher, and I'm going to show you how to make a relative cumulative frequency distribution. It's kind of a mouthful. You would think it would be frequency relative cumulative distribution, but it's relative cumulative frequency distribution, just the way what it's called. And so if you haven't watched the prior two videos, I recommend watching the prior two videos. The first one is the frequency distribution video. The next one is the relative frequency distribution video, and then we are making the relative cumulative frequency distribution video right now. So as I've alluded to, each video builds on the prior, and it's just because I'm using the same numbers, but actually with each version of the video, as we keep building on it, we add a column to the right. And so that's kind of a key part of why I'm doing it with the same number, so that you can see how that goes. So go back and watch them if you haven't. Okay, same numbers up top. That's important. And this is the outcome from our prior video, prior relative frequency distribution video. And then now we're going to do the cumulative part. So the cumulative part is like this. What we do is it's cumulative in that with each row, we can say it's actually each value, each distinct value. We go and we add with each distinct value, we add all of the relative portion onto the current row when we're there. I don't know if that makes sense. Let me show you how it works. Okay, so we'll get started. So with this one, because it is the first row, there's no prior row, although it would be the same value. So it'd be 0.1875. That's it. Okay. So with this next one, what it's going to be is it's going to be this value right here added to this value right here, because it's cumulative. That's the cumulative part. So when we get to this row, see, we add the prior to it, and we add the prior to it. Technically, you could just add them up like this, but if you just add this one out here to that with each one, you'll end up with the cumulative numbers correctly. Okay, so I have these written out so I don't mess up for you. So when we add 0.1875 to 0.125, this is what we get. 3125. Okay. And then the next one, when we have 0.3125 plus 0.125, we end up getting this. 0.4375. And then with the next one, and I'll fill these in. Let's see, make sure I don't make a mistake. 5, 6. So it's 0.5625, and then 0.8125, and then 0.875. That 5 isn't very good, so that's 0.875. And then with the next one, 0.9375. And then because these numbers are not ugly numbers that go on forever or any of those things, once we add these up, they actually it actually ends up equaling 1. And I kind of laugh because doesn't always happen that way, but it just happens to be that way. So I've mentioned in some of the other videos, if you have numbers that go far out, at least go out 4 decimal places. It helps it helps to make it so you don't lose some of the precision in your final calculation. This number right here often is going to be like 0.9987 or something like that. It should not be over 1. If it's over 1, you made a mistake. It'll always be under 1 or 1. But not over. I've had them where you make a mistake, you change some numbers, then you're like, that can't be over 1, and you go back and you find out that you miscounted one of these. That's it. Hopefully this all makes sense to you. One of the other videos to check out would be the grouped frequency distributions, which are quite a bit different. But So essentially I went over how to do the frequency distribution in the first video, then the relative frequency distribution, and now the relative cumulative frequency distribution. So I think, so I hope all of this made sense. Thank you.